Hello, in this video we are going to go over how to use sets to solve problems, and specifically our learning objective is looking at how to solve problems using Venn diagrams. So when things are classified into two distinct sets, we can use a two-set Venn diagram to interpret the information. Let's take a look at an example of how this might work. Our first example says in 2021, there were 41 states that had some form of casino gambling in the state, 45 states that sold lottery tickets of some kind, and 38 states that had both casinos and lotteries. Draw a Venn diagram to represent the survey results and how many states have only casino gambling, how many states have only lotteries, and how many states have neither. So what we do is we are going to start with a two-circle Venn diagram here. Just kind of our standard two-circle Venn diagram. I'm going to label the first circle C and the other one L. C stands for casinos and L stands for lotteries. And we want to fill in the various regions of this Venn diagram. Oftentimes with these sorts of problems, it's easiest to start with the overlap region. So in this case, the overlap region would represent the number of states that have both casinos and lotteries. And in the problem description, it says that there's a total of 38 that have both. So we put 38 in the intersection of C and L. So now we move on and we focus on the fact that it says 41 states have casino gambling. Now, of those 41 states that have casino gambling, 38 of them also have lotteries, right? So that's going to leave only 3 to go in this region. Notice that 3 plus 38 equals 41. Right? So the total inside of the circle labeled C is 41 to represent the 41 states that have some form of casino gambling. All right. Then it says that, 45 states sold lottery tickets of some kind. Now, of those 45 states, we've already accounted for 38 of them, right? Because 38 of them also have casino gambling. So that leaves only 7 over here, right? Notice that inside the circle labeled L, the total is 45. 38 that have lotteries and casino gambling, and then an additional 7 that have only lotteries. Okay. All right, so how many states are accounted for? So we just add up the numbers in the 3 regions, and we have 3 here, plus 38, that's 41, plus 7, that's 48. So we've accounted for 48 states. So that means there are 2 left, which we would put out here, outside the circles, right? Because you need to have all of the numbers in all the regions have to add up to 50 so that we can account for all 50 states. Okay, so now we can answer our questions. There are 3 states that have casino gambling, but not lotteries. There are 7 states that have lotteries, but not casino gambling. And then there are 2 that have neither, no casino gambling and no lotteries, okay? Then there's 38 states that have both. Okay, so that's kind of the general procedure for solving a problem that involves 2 sets. We can kind of analyze the relationships between the sets using a Venn diagram. The process that we went through is essentially outlined right here, okay? Using Venn diagrams with 2 sets. We start with our general Venn diagram. We might label we might use different letters than A and B, kind of choose letters that represent the context of the problem, right? So step 1, find the number of elements that are common to both sets and write that number in region 2. Step 2, find the number of elements that are in set A but not set B by subtracting the number in region 2 from the total number of elements in A. Then write that number in region 1. And then repeat for the elements in B, but not in 2, and write that in region 3. Okay? And step 3, find the number of elements in the universal set that are not in either A or B, and write that number in region 4. And then the last step is to use the diagram to answer specific questions about the situation. One of the most useful applications of Venn diagrams is for studying the results of surveys. This next example analyzes the result of a survey on tattoos and body piercings. So here's our example. In a survey published in the Journal of the Journal of the American Academy of Dermatologists, 500 people were asked by random telephone dialing whether they have a tattoo and or a body piercing. Of these, 79 reported having a tattoo only, 31 reported having a piercing only, and 151 reported having at least one of the two. So we want to draw a Venn diagram to represent these results. And then we want to use the diagram to find the percentage of respondents that have a tattoo and a piercing, that have both and that have neither. Okay? Okay, so let's see. See if I can kind of keep the problem description visible there. And let's put our Venn diagram down here. Okay, do our two circles. I'm going to label this first circle T for tattoo, and this circle P for piercing. All right. All right, so the survey involves 500 people. So that means that the sum of the numbers in all of the regions has to add up to 500. Okay. So in general, it's helpful to kind of focus on the intersection first and see if they tell you the number that goes in that intersection. The intersection would be the number of people surveyed who have both a tattoo and a piercing. Okay. But if we read this carefully, we're not really told what that is, right? That information is not given. If it is given, it's kind of helpful to fill that in first. But if it's not given, then you have to employ a different strategy. So what is given? Well, let's see. What is the 79 number? It says 79 reported having a tattoo only. So tattoo only means they had a tattoo, but they did not have a piercing. So that actually is the number that goes right here, right? Inside the T circle, but outside the P circle. Okay? 31 reported having a piercing only, okay? So that number actually has to go right here, right? Inside the circle labeled P, but outside the circle labeled T. Then it says 151 reported having at least one of the two. So that means 151 had either a tattoo or a piercing or both. So what that tells me is that the sum of this region and this region and this region, they have to add up to equal 151, okay? So that makes it easy to figure out what goes in this region right here. What I can do is I can take the 79 and I can add the 31, and that gives me 110. Then I can take 151 and I can subtract 110, and that gives me 41, and that means 41 has to go in this region right here, right? Because these three numbers have to add up to equal 151 because of what's given in the problem right here. Okay, so far I have 3 of the 4 regions. I have a number in 3 of the 4 regions. The region that I don't have a number in is this region outside the circles. To figure out what goes there, I have to know that the survey incorporates 500 people, right? So that basically means everything that's left goes here. So if I add up the numbers in these 3, I already know those add up to 151, right? Because that represents the number that have a tattoo or a piercing or both. So what's left is going to be 500 minus 151, which is equal to 349. And that goes out here. So there's my completed Venn diagram. Okay. So then what are we asked to find? Well, it says, use your diagram to find the percentage of respondents that have a tattoo, the percentage of respondents that have a piercing, that have both, and that have neither. Okay? Okay, so first of all, let's start with tattoo, right? What is the percentage of respondents that have a tattoo? Well, first of all, I got to figure out the number of respondents that have a tattoo. That's going to be the total number of individuals represented by the circle labeled T. So it's going to be 79 plus 41, right? Because some of them have a tattoo only, some of them have both. Okay, so tattoo, so we got 79 plus 41, which equals 120. We want to express that as a percentage. So that would be 120 out of the total, which is 500, and multiply that by 100%. If we work that out, round to the nearest percent, I get 24% have a tattoo, or have tattoos. Okay. Okay, piercings, similar, right? I would figure out the total number of individuals inside this column, this circle labeled P, right? So that would be 41 plus 31, which equals 72. So then express that as a percentage, 72 out of 500 times 100%. And put that, if I work that out, I get about 14%. Okay. Have piercings. Okay, then it says to figure out the percentage that have both. Well, from the diagram, I can see that 41 have both, right? So as a percentage, running out of space here. Sorry, I got, so 41 out of 500 times 100%. That works out to be about 8%. Have both. And then 349 have neither, so as a percentage, 349 out of 500, that works out to be about 70%. Have neither. All right, so there you go. This is just another picture of my filled out Venn diagram, right, with the region numbers labeled. Okay, so far we've looked at a couple of examples that involve 2 sets. So we've looked at a 2-circle Venn diagram. When a classification problem or a survey consists of 3 sets, a similar procedure is followed, but we just use a Venn diagram with 3 sets. We just have a little bit more work to do since there are now 8 regions instead of 4 to fill in. So let's look at some examples involving 3 circle Venn diagrams. Here's our first one, example 3. A criminal justice major is studying the frequency of certain types of criminal crimes in a nearby county. He studies the arrest records of 300 inmates at the county jail, specifically asking about drug-related offenses, domestic violence, and theft of some sort. He finds that 194 had been arrested for theft, 210 for drug offenses, and 170 for domestic violence. In addition, 142 had arrests for both theft and drugs, 111 for both drugs and domestic violence, and 91 for both theft and domestic violence. And 45 had been arrested for all 3. Draw a Venn diagram to represent these results and find the number of inmates that had been arrested for only drug-related offenses, theft and domestic violence, but not drugs, theft or drugs, none of these offenses. Okay, so let's start by just sketching our Venn diagram. I need a little bit of a bigger one. You want 3 circles. I'm going to label my circles T for theft, D for domestic violence, D for drug-related, and then we'll say DV for domestic violence. Okay. So let's see what we're given here. Again, if you can fill in the innermost place where all 3 circles overlap, it's kind of helpful to start there. So if that information is given, then we'll start there. If I read through this carefully, I do see that it says 45 had been arrested for all 3. Okay, so that means 45 goes right there. See if I can get a better 5. My pen is kind of messing up on me. Sorry about that. I don't know why it's doing that. 45. That's a little better. Okay, so then we read over and see what else it says. Okay, it says he studies the arrest records of 300 inmates. So that means the sum of all of the regions, they have to add up to 300. Specifically asking about drug-related offenses, domestic violence, and theft of some sort. Okay, he finds that 194 had been arrested for theft. So that basically means that all the regions inside the circle labeled T have to add up to 194. So far, I have one of those regions filled in, the 45, right? 210 for drug offenses. All the regions inside the D circle have to add up to 210. 170 for domestic violence. All the regions inside the DV circle have to add up to 111. Okay, 170, sorry. Okay, then he said 142 had arrests for both theft and drugs. Okay, so 142 had arrests for both theft and drugs. So that is where these 2 circles overlap. So that basically means this region plus this region has to add up to 142. Okay. So what does that look like? We have 45 in there, so let's take 142 and subtract 45, and what does that give me? 97, right? So 97 has to go right here. Okay. 111 had arrests for both drugs and domestic violence, okay? So that basically means these 2 regions right here have to add up to 111, okay? So we're going to take 111, and I'm going to subtract out 45, which gives me, what, 66? Okay, 145 minus 40. 111 minus 45 is 66, right? So that tells me that this region has to be 66. 66 plus 45 is 111. That represents the number who had been arrested for both drugs and domestic violence. Okay. Okay, then it says 91 for both theft and domestic violence. Okay, so these two regions represent theft and domestic violence. So that means this region plus this region has to add up to 91, right? So to figure that out, I'm going to take 91 and I'm going to subtract the 45, okay, which gives me 46. So that gives me this right there. Okay. I still don't like my 97 there. Maybe. Oh, shoot. Sorry about that. Did not mean for that to happen. Try this again. Sometimes my electronic pencil just doesn't work very well. Is that right? 45, 66. All right. Okay, so this is what we're looking like so far. Sorry, my circles are not perfect circles, but we'll make the best of it. Okay, so now we should kind of go back to the top, and we can fill in what's left based off of these numbers. So 194 had been arrested for theft. So that means all the regions inside the circle labeled T, they have to add up to 194. So I can basically take 194 minus the sum of these three regions to figure out what's left. Okay, if I do that, this is going to end up being a 6. Okay, because 6 plus 97 plus 46 plus 45 adds up to 194. Okay, if I add up these four numbers, it adds up to 194, which had been arrested for theft. 210 were arrested for drug offenses. Okay, so that means I'm going to put a 2 right here. That's because all four of these numbers have to add up to equal 210. Okay, so 97 plus 45 plus 66 plus 2 has to add up to equal 210. Okay. Just double check. It does. All right. And then it says 170 had arrests for domestic violence. That tells me that this number right here has to be a 13. So why is that a 13? Because 170 were arrested for domestic violence. So that means all of the numbers inside the circle labeled DV have to add up to 170. Okay. Okay. And the last thing I need to do is I need to put a number in the region out here, right? So remember that the sum of all the regions has to add up to equal 300 because it says the survey was of 300 inmates. Okay. So if I add up the numbers in all of these known regions and then subtract that from 300, I'm going to get 25. Okay. Basically, all the numbers in all 8 regions, they have to add up to equal 300. And if you add these up, you'll see that they do. So this is my completed Venn diagram. Okay. And then I want to answer these questions right here. How many were arrested for only drug-related offenses? Okay. That will be the number in this region right here, inside the D circle, but outside all the other circles. So that would be 2. Okay. How many were arrested for theft and domestic violence, but not drugs? Okay. So that would be the overlap between the T and the DV circles, but outside the D circle. So that would be this number right here, which is 46. How many were arrested for theft or drugs? Basically, either theft or drugs, right? So that would basically be the sum of all the numbers inside the T circle and the D circle, right? But it would not include the 13 because that is outside of those circles, right? So if I add those numbers up, I basically get either theft or drugs, so 6 plus 97 plus 45 plus 46 plus 2 plus 66. That is a total of 262 that were arrested for either theft or drugs. And again, that was found by adding up the numbers in all of the regions inside the T and the D circle. And then how many were arrested for none of these? Well, that would be this number out here, the 25, okay? That's what that would be. Okay. All right. Let's look at one more example here. Scroll down. So instead of writing a general procedure for solving problems using a 3-circle Venn diagram, we'll just solve one more example. And this time, the information provided is a little bit different. The key, which is really the key to all these problems, is finding information that applies exactly to certain regions in the diagram, and then use subtraction to find other regions at one at a time, right? So in the previous example, we started by filling in the inner region, the overlap of all 3 circles. In this example, that the number that goes in that middle region is not given, so we have to fill in some other regions first. Okay? So here's our example. 3 of the most dangerous risk factors for heart attack are high blood pressure, high cholesterol, and smoking. In a survey of 690 heart attack survivors, 62 had only high cholesterol. Among those 3 risk factors, 36 had only smoking, and 93 had only high blood pressure. There were 370 total with high cholesterol, 159 with high blood pressure and cholesterol that didn't smoke, and 23 that smoked and had high cholesterol but not high blood pressure. Finally, 585 had at least one risk factor. Draw a Venn diagram representing this information and use it to answer the following questions. How many survivors had all 3 risk factors? How many had exactly 2 of the 3 risk factors? How many had none? And what percentage were smokers? Okay, so we're going to need a Venn diagram with 3 circles. I want to kind of try to keep my problem description up here so we can refer back to it. So let's see if we can squeeze it in down here. Okay, we're going to label this first one. We'll say SM, that stands for smoking. We will label this one C for cholesterol, and we'll label this one BP for blood pressure. Okay, so the inner region here would be the number who had all 3 risk factors. It would actually be the answer to question A, but it's not given. So what is given? Okay, maybe we'll just kind of start from the beginning. 3 of the most dangerous risk factors for heart attack are high blood pressure, high cholesterol, and smoking in a survey of 690 heart attack survivors. Okay, let's pause there. That's the total. So that means the sum of all the regions has to add up to 690. Okay, then it says 62 had only high cholesterol. Only high cholesterol. So that means they had high cholesterol, but not either of the other 2 risk factors. So that tells me that the 62 can actually go right here, right inside the C circle, but outside the other 2. Okay, let's keep going. 62 had only high cholesterol among these risk factors. 36 had only smoking, okay? Only smoking, but not the other 2. So that goes right here in this region, right? Inside the smoking circle, but outside the other two. And 93 had only high blood pressure. Okay, so the 93 goes in this region right here, inside the blood pressure circle, but outside the other two. So that would be 93. All right. Keep going. There were 370 total with high cholesterol. So that means inside the C circle, the 4 regions inside the circle labeled C, they have to add up to 370. So far, I only know the 62 inside one of those regions. I still have 3 regions that I'm not sure about. So I can't do a whole lot with that right now. So let's keep going. 159 with high blood pressure and cholesterol that did not smoke. Okay, so we have high blood pressure and cholesterol. So that means the overlap between BP and C, but did not smoke. So now we're looking at the number that goes right here in this region, right? Overlap between BP and C, but not SM, basically. So that's 159. Okay. Then it says 23 that smoked and had high cholesterol, but not high blood pressure. Okay, so that number has to go here, right? So the overlap between smoking and high cholesterol, but outside of high blood pressure, right? So we're looking at 23, goes right there. Finally, 585 had at least one risk factor. Okay, so that means that the sum of all of these regions, they have to add up to 585. But there's still 2 regions that I don't know. If I can figure out what goes into one of these 2 regions, I could figure out the rest by subtracting the total from 585. So let's back up a little bit and see if we can do something with this number. There were 370 total with high cholesterol. Well, now in the high cholesterol circle, I have 3 of the 4 regions filled in. So I can figure out this region by taking the sum of 23, 62, and 159 and subtracting that sum from 370. So let's do that. Okay, so 23 plus 62 plus 159. What does that equal? 23 plus 62 plus 159 equals 244. Then we take the 370 total with high cholesterol, 370 minus 244. That equals 126. So now I can put 126 in here, okay? And notice that the sum of all the numbers inside the circle labeled C, they now add up to 370 to match that number. Okay. So now, to figure out the numbers in this region, I can use this information. 585 had at least one risk factor. So that basically means the sum of all of these regions has to add up to 585. So what I could do is I could add up the known numbers. Okay, so we'll just say 36 plus 23 plus 62 plus 126 plus 159 plus 93, right? 36 plus 23 plus 62, 126, 159, 93. Let's just see what that equals. 36 plus 23 plus 62 plus 126 plus 159 plus 93. It's 499. So then I take the 585 and I subtract 499 from it. 585 minus 499 equals 86. That goes right here. Sorry. Right here. All right. So now, if we add up all the numbers that we have written down, they add up to 585, which is the total that had at least one risk factor. The survey included 690. So the last region would be those out here, those who had none of the three risk factors. And that would be found by taking the total, 690, subtracting the 585 that had at least one risk factor, and that works out to be 105. And that I can put down here. So there's my Venn diagram. Now I can answer the question. How many survivors had all three risk factors? All three would be the intersection of all three circles. That would be 126. How many had exactly two of the three risk factors? Well, for that, I have to add up the numbers in the regions where exactly two overlap, right? So 23 had smoking, cholesterol. 159 had high blood pressure and high cholesterol. 86 had high blood pressure and smoking, right? So we would be taking, if I add those up, maybe I'll just do it over here, 23 plus 159 plus 86. That works out to be 268. Okay, so 268 had exactly two of the three risk factors. How many had none? That would be the number out here, right? 105 had none. What percentage were smokers? So for that, we got to figure out the total number of smokers and then express that as a percentage. So I have to add up all the numbers inside the circle labeled the smoking circle here to start with. So that gives me 36 plus 23 plus 126 plus 86. Okay. That works out to be 271. And then 271 out of the total, which was 690, times 100%. If I do the math, that works out to be about 39%. Okay, so 39% were smokers. Okay, so there's a few examples of how to analyze set relationships and survey problems using Venn diagrams. So we'll stop here. We'll stop this video here. Thank you so much.